Okay, in section 4.2 we are going to look at two triangle congruents, side 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 or SSS and side angle side or SAS. The side 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 postulate says if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. And we have an example of two triangles where their corresponding sides are congruent, and therefore they are congruent by the side 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 postulate. Alright, let's look at an example of the side 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 postulate. Number 1 says the bridge girders are the same size, write a proof. And we are given that side AB is congruent to side CB and side AD is congruent to side CD. We want to prove that triangle ABD is congruent to triangle CBD. And you'll notice in our figure we have that yellow triangle and our congruent sides are already marked. So the first thing whenever writing a proof is to list down our givens. So number 1 in my proof, we have side AB is congruent to side CB and side AD is congruent to side CD, and my reason is that they are given. Alright, so you notice we have two congruent sides. In order to use the side 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 postulate, we just need one more congruent side. So looking at my figure, I notice that triangle ABD and triangle CBD share the side BD. So that means that side BD is congruent to itself. And we saw in the last section, we can say that because of the reflexive property of congruence. Alright, now that's my third side, and now I have enough information to say my triangles are congruent. So number 3, triangle ABD is congruent to triangle CBD, and my reason, side, side, side. Alright, and we are done with our first proof. The word included is used frequently when referring to the angles and the sides of a triangle. So referring to our triangle on the right, triangle ABC, we're going to answer a few questions on sides and angles that are included. So number 2 says, what sides include angle C? So in other words, what sides contain this angle here? And that would be side AC and side BC. Okay, number 3, what sides include angle A? So which ones contain this angle? Well, that would be side BA and side AC. And finally, what sides include angle B? Well, that would be side BA and side BC. All right, now looking at sides. What angles include side AC? So what angles are part of this side here? That would be angle A and angle C. What angles include side AB? Well, that would be angle A and angle B. Note it's the two angles that make up that side. And finally, what angles include side CB? Angle C and angle B. The side angle side postulate, or SAS, says that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So looking at our figure, the included angle would be the angle that is in between our two congruent sides. So that would be this angle and this angle, which we do know these angles are congruent because they are vertical angles. So the two triangles below are congruent by the side angle side postulate. In our next examples, it says, what other information do you need to know to prove the triangles congruent by side angle side? So in number 8, we're trying to prove that triangle ADC is congruent to triangle BCD. So ADC is this triangle here, and BCD is this triangle here. Well, we are already given one pair of congruent corresponding sides, and you notice that the two triangles overlap and share side DC. So DC is congruent to itself by the reflexive property of congruence. The only thing that we're missing here is an angle, and we said to use the side angle side postulate, that angle needs to be included between our two sides. So that means I'd need to know that this angle is congruent to this angle. So the piece of information I'm missing is that angle ADC is congruent to angle BCD. If we had that information, then we would be able to prove that those two triangles are congruent. In the next example, we're trying to prove that triangle YXZ is congruent to triangle WZX. Notice we have one pair of congruent sides. We have XZ being congruent to itself by the reflexive property. So the only thing we're missing is a pair of angles that's included between our two sides. So I would need to know this angle congruent to this angle. So we're missing that angle WXZ is congruent to angle YZX. If we knew that information, then we'd be able to prove the two triangles congruent by side angle side. And in number 9, it says, can you prove that triangle AEB is congruent to triangle DBC? Well, we have two pairs of congruent sides. I would have congruent angles because of vertical angles, but the question is, are my congruent sides corresponding? Meaning, do they match up? I see that EB and BC do. However, my other two pairs of sides are not corresponding. So the answer is no, we do not have corresponding sides congruent. So corresponding sides are not congruent. All right, let's look at an example of writing a proof using the side angle side postulate. So it says that we are given that angle RSG is congruent to angle RSH. So it would be this angle congruent to this angle. Side SH is congruent to side SG. So these sides are congruent. And we want to prove that triangle RSG is congruent to triangle RSH. So first thing, let's write down our given. So angle RSG congruent to angle RSH, and side SH is congruent to side SG. And our reason is that they are given. All right, so I have one angle, one side, I'm missing another side. Well, we see that the two triangles share side SR, so it is going to be congruent to itself. So side SR is congruent to side SR by the reflexive property of congruence. Now I have my third side, and my angle is included between my two sides. So I can say triangle RSG is congruent to triangle RSH by the side angle side postulate.